In the last video, we discovered that when we moved or transposed the melody of Twinkle Twinkle Little Star from C to F using diatonic intervals to guide us, we came up with a version of the melody that was really close, but not exactly close. There was that one note, that B, that we had to adjust with our ears to a B flat. Became and the question is, why didn't diatonic intervals give us the right answer? They gave us an answer that was really close, but why didn't they give us exactly the right answer? And you may already be thinking of a reason why. You remember when we talked about chromatic intervals in the previous video series. We said that every interval has not one, but either 3 or 4 different versions, or 3 or 4 different qualities. With the perfect intervals, we have diminished, perfect, and augmented. With the imperfect intervals, we have major, minor, diminished, and augmented. And each of those qualities has a different number of half steps. So for instance, a perfect fifth has 7 half steps, an augmented fifth has 8 half steps, and a diminished fifth has 6 half steps. So in a way, diatonic intervals, if we're talking about just the distance in letter names, that's a little bit of an imprecise measure. And chromatic intervals allow us to be a little bit more precise, allowing us to talk about not just the distance in letter names, but also the distance in half steps. So let's investigate Twinkle Twinkle Little Star in terms of its chromatic intervals. Now remember, a chromatic interval always has 2 parts. It has a number, which is the diatonic interval, the distance in letter names, and it has a quality, major, minor, augmented, diminished, perfect. So, let's go to our first interval from C to G. And I'm ignoring the unisons here because we know that those will just be the same note no matter what. I'm just interested in the intervals right now that are not unisons. So we know that C to G is a fifth, but what kind of fifth is it? So what are we going to do? We're going to count up the half steps. So C0, C sharp 1, D2, D sharp 3, E4, F5, F sharp 6, G7. So C to G is a fifth with 7 half steps, which means that is a perfect fifth. So what I'm going to do is I'm going to erase this, and I'm going to write my P5, my perfect fifth symbol, and just give us a little up arrow just to let us know that we're going a perfect fifth up. Okay, great. So we know that the next interval from G to A is a second, but what kind of a second is that? Well, if we have G, 0, G sharp 1, A2, that's a second that has 2 half steps. That is a major second up. And let's go to the next one. We have A going down to G. We know that that's a second down. A, 0, A flat 1, G2. So that's a second with 2 half steps. And again, that's a major second. So that's going to be a major second down. From G to F is a second, and what kind of a second is that? So let's figure that out. G0, G flat 1, F2. So that is a major second down, a second that has 2 half steps. Then from F to E, we know that that's a second, but how many half steps are we moving? We're moving F0, E1. So that is a second with 1 half step, which means that is now a minor second down. Now let's go from the E to the D. E down to D is a second, but what kind of a second is that? Let's count the half steps. E0, E flat 1, D2. So that's a second with 2 half steps, which means that is a major second. Now I'll write that right here. Major second down, and then we have one more interval. And that's from D down to C. And again, we know that's a second because D to C is the interval of a second diatonic. But how many half steps do we have? Well, we have D, D flat 1, C 2. So that is a major second, a second that has 2 half steps. Now we've given ourselves a really, really precise map of the melody of Twinkle Twinkle Little Star. Perfect fifth up, major second up, major second down, major second down, minor second down, major second down, major second down. In the next video, we're now going to investigate the melody that we wrote starting on F, but now investigate it with this very precise map of chromatic intervals and see what we discover.